So we look at a graph like this. This graph has multiple lines on it. It is a distance x over time graph. Okay? Object A is a steeper line than object B. So object A is going faster. This point right here is zero distance. The object at zero distance is zero time and zero distance, right? Because this is distance, the x means distance. This is distance, the x means distance. So if you look, this is you. You are at zero distance, right? So if you're standing here, this object is going away from you faster. But this object right here, it was never beside of you. It started away from you. This object B is going slower, but it had a head start. Because at time equals zero, it wasn't here where you were. It was over there. Does that make sense? And then when whoever yelled start, it started going very slowly. And then A quickly catches up to it and then passes it. We know it catches up and passes it at this point because they're at the same distance and the same time. In 5 seconds, object A caught object B, and then by 5.1 seconds, it had passed it and gone on. Does that make sense? So this is a distance over time graph. All right, let's click on to the next one. So another graph you could see that's a distance over time graph. You're here. You are at zero. This is your point of reference. Every graph, every time we talk about motion, the graph has to have what we call a point of reference, right? The observer is making the graph. So you are 0, 0 at the beginning of the graph. That's you standing there. In this situation, this object was away from you, and you yelled start, and then it started driving back towards you. This is time going by, right? So it's coming back towards you. It's coming back towards you as time passes. And then eventually, we have to assume it's going to come all the way back to you. This may be a remote control car that you were driving, and then you had it drive back to you. That would be a graph of that happening. Does that make sense? What if this graph was really steep? What could you tell me about that car? If the line was steeper, what could you tell me about the car? It's going faster. Does that make sense? Because it would get back to you in less time. So if the line looked like this, yoink, that car came back to you, but in less time. It's going faster. A steeper line, just like in the last graph, means a higher velocity. Everybody with me? All right. This graph right here, you will see. This is distance, this is time. This is you. You start the time's rolling. And the object is 4 meters away from you. And then a little bit later, it's still 4 meters away from you. Then a little bit later, that guy's parked. It's just not parked beside of you. It's over there. And it's not doing anything. It's boring. Or maybe this is awesome because this is a grizzly bear. And time's going by and it's not getting any closer to you. Of course, it's also not getting any further from you, so that's kind of a bummer if it's a grizzly bear, right? Did y'all see that video of like the grizzly bear that like comes up and like hugs the woman? It was out like a week or two ago on social media. They're like hiking in a forest, and I think it was fake. Anyway, not what you're looking for. All right? And then this distance over time graph, this line is curved, and you need to write this sentence in your note. A curved line on a distance over time graph shows acceleration. As long as it's a distance over time graph and you see a curve, the object is accelerating. Now this is going to look funky to you. This object is obviously Lillian. This object is doing what? The line's getting steeper and steeper, so is it speeding up or slowing down? Speeding up, that's right. At first it's going slow, and then it's going faster and faster and faster and faster. Does that make sense? So what would a graph of an object that was going really fast at first and then slows down look like? It would look like the opposite of this. These graphs right here, they look like this. This is an object that's going really fast at first, and then it slows down. This object is also accelerating. We like to use the term decelerating, right? You can say decelerating for slowing down, but really, the word accelerating only means change. You want to jot that down in your note. Accelerate just means to change. It can mean speeding up. It can mean slowing down. It can also mean turning. If you're driving your car and you're on cruise control and you turn the wheel, you just accelerate it. Here's how you know. Let's say you're sitting in the back seat of that car and you're blindfolded for some bizarre reason, and you don't have a seatbelt on for some bizarre reason. If you're sitting in the back of a car, the cruise control's on, it's going 55 miles per hour, you're wearing a blindfold, you're sitting there. If somebody turned the wheel, can you feel that? That's what acceleration is. If they hit the gas, could you feel that? Yes, that's accelerating. If they hit the brakes, could you feel that? Yeah. Anytime there's a change in the velocity of an object, that's accelerating. And you're like, Mr. Perkins, if you turn the wheel, you can still be going the same speed. Correct. So we need to talk about what V for velocity actually means. Velocity means speed in a certain direction. Write this down, please. Velocity is speed with an arrow. Speed is how fast you're going. Velocity is how fast you're going and what direction you're going. So your velocity could be 10 meters per second north. Your speed could be 10 meters per second. If you turn the wheel, your velocity could be 10 meters per second northeast. But your speed is still just 10 meters per second. Does that make sense? So velocity and speed aren't really the same thing.